Good morning, good afternoon, good evening. It's the Oracle of Chinemkotu and welcome back. Today we have got a question that appeared in the IGCSE S level June-July exams of 2020. It is an interesting question in that it does not deal directly with numbers. It deals with the variables, and a lot of students struggle where the numbers are replaced by symbols or variables. This is a typical example of a question that you would not grasp from lessons in the class, but a question that you would appreciate and understand by going through it and practicing it. And if it comes in an examination after you have seen it before the exam, it will make a lot of difference. If it is just given to you and you are seeing it for the first time, it might actually shock you because it is just dealing with the variables, no numbers, very few numbers here and there, and but in general it contains all the principles that we have already covered in one or more of the past questions that we have already uploaded on the YouTube. And we are going to add it to a group of questions that deals with curves and the lines, where we apply, here we are required to apply both differentiation and integration. The diagram is shown here, and basically from looking at the diagram before we even read the question itself, you can see that the line OA and the curve all pass through the origin, so the y-intercept and the x-intercept are both equal to 0. So at the end of the day, you can see that the intercepts are exactly 0 because both the curve and the line pass through the origin. So the question itself says, and also if you look at this point of where the curve just touches the x-axis, at that point obviously you know that that is a repeated root and that's b. And the question itself says the diagram shows part of the curve with equation y is equal to x cubed minus 2bx squared plus b squared x, and that is the curve we are talking about, and that is a cubic factor or cubic equation. So, and the line OA, that's the line OA, you know that that is the line, and from our previous engagement we know once we hear the word line, we know that its equation is equal to y is equal to mx plus c, where m is the gradient of the line and c is the intercept, y-intercept, that is the value of y when x is equal to 0. We are then told that A is the maximum point on the curve. What does that tell us? If it is a maximum point on the curve, that means the curve is turning there and it is moving from the highest point to below that point. And the x-coordinate of A is A, small cap A, so we know that there the x-axis is equal to A. We can get what y is later on, and the curve is a minimum point at B, so that means we know that the curve there is also turning from the lowest point going up, and that's a minimum point, and the coordinates there, x is equal to B and y is equal to 0, where A and B are positive constants. So then the first question, it has got 4 part questions, A, B, C, and D. Question A says show that B is equal to 3A, and B says find the coordinates of A, we already know that the x-coordinate of A is equal to small letter a, so we need to find y. Then it says find the equation of the line OA, and we know that this is a line, so the form of the equation is y is equal to mx plus c, and already as we said that the line is passing through the origin, we know that c should be equal to 0 because that's the intercept, and so the y-intercept of a line that passes through the origin is equal to 0. If the shaded area is equal to ka to the power 4, find the value of k. So for you to get the shaded area, you need to know the equation of the line, and you subtract the equation of the line from the equation of the curve, because the line is below the curve. And then once you get the area, you equate it to ka to the power 4 and get the value of k. So basically, in a nutshell, that's what the question is talking about. So we are going to start by looking at question A, which says that show that B is equal to 3a. So we have been told that the maximum point of the curve y is equal to x cubed minus 2bx squared plus b squared x is at a. So at any turning point, the gradient of the curve at that point is equal to 0, and the gradient of a curve is given by its derivative. So the first point is that the gradient of a curve is given at any point of the curve by the derivative of the equation of the curve. And the value of the coordinates at that point. So we already know that the coordinate of the curve at A is equal to small letter a. So we will look for the gradient of the curve at A and equate it to 0 because it's a turning point, and then we will substitute for the value of x with A, and we will get the relationship between B and A. So we have y is equal to x cubed minus 2bx squared plus b squared x, and therefore dy dx, which is the derivative of that curve, is equal to, we differentiate that expression there, which we can call equation 1, so we can refer to it without any ambiguity. So the differential there, this will be 3x squared minus 4bx plus b squared. So we are using the general formula of finding a derivative, where you multiply by the power and then subtract the power as your new power. So the power here is 3. We say 3 multiplied by x, and then 3 to the, and then x, we raise x to the power 3 minus 1. Here we multiply by the power of x, which is 2. So this gives us minus 4 plus b, and x, we raise the x to the power 2 minus 1, which becomes just x. And here we have got 1x to the power 1. We multiply b squared by that, it gives us b squared, and we raise x to the power 1 minus 1, which is x to the power 0, and that goes to 1. So A is the maximum point of the curve, and therefore a turning point and the gradient of a turning point is always equal to 0. So 3x squared minus 4bx plus b squared is equal to 0 at A. And at A, we know that x is equal to small letter a, you can call this equation 2. So then substituting x with a, we have so we can say substituting with the x with a in equation 2, we have 3a squared minus 4ba plus b squared is equal to 0. So this is a quadratic equation in both a and b. So we can actually factorize and get 2 brackets, which is a binomial expansion, and here we can say 3a, and therefore here we have a. Since we have b squared, we can have b there and b here, and here we've got minus 4ba, and we know that 3ab and the plus ba gives us 4, but here we have a plus and a minus there, So we will have both minus and minus, so that we can have a minus 4ab and a plus b squared there. So that means any one of these two binomial expressions can be equal to 0. So we can have 3a minus b is equal to 0, or a minus b is equal to 0. And so we have here b is equal to 3a, or b is equal to a. So this is what we've been asked to show. We can therefore say, therefore, from the solution, b is equal to 3a as required, and b is equal to a is not feasible from the diagram. Therefore, b is equal to 3a as required. And therefore, question A is answered. And these are the basic steps that you are required to go through to get your solution to A. And we can come this side of the board and do B. B requires us to find the coordinates of A. We are already given that the x coordinate of A is A. Therefore, from equation 1, we can say y is equal to a cubed minus 2b a squared plus b squared a. And what I've done there is, since we know that the value of x at a is a, small letter a, we just substitute for x using a in the equation, in equation 1, and therefore we get y is equal to a cubed minus 2b a squared plus b squared a. However, from the solution of A, we know that B is equal to 3A. So therefore, if we call this equation 3, so using equation 3, we have y equals to a cubed minus 2 times 3a bracket times a squared plus 3a squared times a, and therefore we have y is equal to a cubed minus 6a cubed plus 9a cubed. So therefore y is equal to, that would be minus 5a cubed plus 9a, that gives us 4a cubed. So therefore the coordinates of A are bracket A for a cubed, and the solution is done. So we have shown how you get A and how you get B, and all of these are given as the variables either A or B. We chose to show everything in terms of A, as our first solution needed us to show that B itself was equal to 3A. So we know now that the coordinates of A are small letter a for x and 4a to the power 3 for y. Then now that we know the coordinates of A and also the fact that OA passes through the origin, we can find the equation of the line OA. So we are going to wrap the board and then we will do C and D.